Welcome back, my friends, to Physics and Engineering with STEM Marin, day one of our asynchronous learning experience. Okay, so the first thing that we're going to do today is we are going to set up your notebooks, your science notebooks. So first, you will need a bound notebook of some kind. You might like a spiral bound notebook. Lined paper is fine. These guys are probably the easiest ones to get. You might even have them at home. Or you can get them at Target or, I don't know, anywhere that sells paper. Another option that I really like is a bound notebook with like a cloth binding. This one has graph paper on the inside, which is really cool. I love working with graph paper. It makes me feel extra sciencey and mathy. And we're going to do some graphing, so having the graph paper would be like an added bonus. So if you can get one of these, that's probably your best option, but spiral bound is just fine. Or if you're feeling real fancy, this one I just discovered. It is graph/college rule. So check this out. It's wild. Graph paper on top, lined paper on the bottom. Mind blown. Okay, so first you are going to take your new science notebook and we are going to set it up with your table of contents. So the first page, as soon as you open, you're going to title right up here at the very top, table of contents. So I'm going to grab a pen and I'm going to write in table of contents at the very top of contents. Great. Just like that. Then through here, every time you add a new page, you are going to add what is on that page. So the first page that we're going to do today is going to be page number 1. Not shockingly, we start at the very beginning. A very good place to start, I hear from Julie Andrews in The Sound of Music. So page number 1, and that's going to be Intro to Physics and Engineering Notes. Boom. I now have my page number 1. Okay, so leave the entire first page, flip over, leave the back side of that first page, leave the next page also open because we're going to have a lot of stuff in this table of contents. And then finally on page number 3, we're going to make this page 1. And I'm going to put a 1 in the upper right-hand corner like that. And now we are good to go. So let's start with our Intro to Physics and Engineering notes. Okay, so here we are. If I can pull up and make the connection. No. Stand by for technical difficulties. And we're connected. All right, so we're going to start with this Intro to Physics and Engineering notes, and I've posted this as a hard copy for you as well so that you can see it there. So let's zoom in a little bit and start with our title. So we're going to title this Introduction to Physics and Engineering, Intro to Physics and Engineering, and we're going to make it page number 1. So right over here, I'm going to say page number 1 at the top. All right, so let's talk about what is physics and engineering. So let's start with physics. Physics is the study of how objects in the natural world behave, including matter, motion, energy, and force. Okay, so breaking that down, it's anything in the natural world that does one of these things. So matter. What's matter? Nothing. What's the matter with you? Ha 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 ha. Oh, Mr. Williams, you're so funny. Matter is stuff, right? Anything that's made of stuff counts as physics. Motion is movement. Anything that moves is part of physics. Energy, anything that has energy or transfers energy is part of physics. And force, anything that pushes or pulls or gets pushed or gets pulled is part of physics. So that narrows it down to everything in the entire universe. Physics is the study of how everything works. It's awesome. Okay, thing number 2 that we're going to be studying is engineering. And just to be clear, as I am going through this, you are writing all of this down on page number 1 of your science notebook. If I write, you write. Okay, so engineering is the application of knowledge to design, build, and maintain things. So physics is the knowing about stuff, right? How does stuff work? Thinking about it theoretically. Engineering is applying that knowledge to do something. And the things that we're going to do are designing things, building things, or maintaining things. Maintaining, we kind of forget about quite a lot because it's less glamorous, but that's kind of what makes the world work, is keeping things going. It's by far the most efficient part of engineering is the maintenance. We're going to do a lot of designing, we're going to do a lot of building, we're going to think a lot about maintaining and doing things the right way. But if you are designing something, building something, or maintaining something, and it doesn't have to be a physical thing. It could be a software program on your computer. It could be an idea. Can you design an idea and then build out that idea? That's part of engineering. So there's a bunch of different types of engineering. And here are some common types of engineering. So let's start with chemical engineering. Chemical engineering is when an engineer is working with any substance or chemical. So that might be designing plastics. That is a chemical, it's a substance. It could be working on lubricants in between things. It could be gas and oil. It could be any kind of industrial product, working with, like, let's say our tabletops. How did we make those? In order to, actually, that's fresh on my mind right now because our new science building, there's only one factory in the entire US. Actually, there's 2 factories in the whole US that make the material for our countertops in our new science building. And one of them burned down 3 months ago. So now there's one factory. And so we've been delayed by a few months because we can't get the countertops in. So that's a chemical engineering thing. How do we actually get the chemicals to make the countertop so that they don't get burned, so that they're secure, so they're chemically resistant, et cetera. Civil engineering. Civil engineering would be working with buildings and infrastructure. So roads, bridges. This is kind of probably the kind of engineering that you think about, like roller coaster tycoon engineering. Can I design something and build something? That's generally civil, but it's also working with like sewer systems, electrical grids, just like big scale stuff. Electrical engineering is working with things that use electricity. So if it turns on, like your computer, it is part of electrical engineering. Lighting systems, anything that would have an electric current, batteries, whatever, is electrical engineering. And then mechanical engineering is working with machines and systems. Now, many machines and systems also are going to use electrical. So you're going to have a lot of like electrical mechanical overlap. But mechanical engineering is working at like, how do things function together? How do you put a system together? Gears, things of that nature. And then there's so many other types of engineering, anything that can be designed, built, or maintained. So environmental engineering, biomedical engineering, aerospace engineering, working with planes and spaceships, optical engineering, working with light and lasers, vision, computer science engineering, naval engineering, working with boats and water, sound engineering. So let's just take a case study. We here at San Marin are in the process of finishing up our brand new STEM Marin building. We've had a few walkthroughs. It looks awesome. So that incorporates all of these types of engineerings in. Well, not quite all. There's very little aerospace engineering, but we kind of start with a geosciences engineering, so like a geologic engineering, where you got to test the ground and make sure it's actually secure enough that we can put the size building that we want there. Then you've got a civil engineer who's going to draw out the designs for the building itself. The chemical engineering we talked about, we need special countertops. There's obviously electrical systems that run through the building. There's going to be a lot of mechanical stuff, our air conditioning, all the tools and machinery that are in there. There's going to be the environmental part of the engineering. So looking at the outside features and how do we use the right materials to keep it cool inside and when it's hot out, and warm inside when it's cold out, and do so in the most environmentally friendly manner possible. There's some sound engineering. They just put in these like sound deadening panels on the walls because the first time we walked through the hallways, it was so echoey. And you imagine if we put 300 students walking through those halls, it's just going to be like a noise thing. So they put in some like soundproof paneling in those hard hallways so that it would kind of quiet things down and not feel like you're inside of a sound box. All right. So those are types of engineering. The way that we're going to be doing engineering in this class is using the engineering design cycle. So here is the engineering design cycle. And I'm going to go through and just kind of talk through what this would look like. So for the engineering design cycle, we start the engineering design cycle by identifying the need. So number one, you actually have to figure out what you are engineering and why you're engineering it. You don't want to build something just for the heck of building it. You want to have a purpose. In our case, our purpose for the new science building was we want to do some really cool science teaching, and having a space that's conducive for students learning is going to be really helpful with that. It's going to let us do the really cool teaching that we want to be able to do over the next 4 years. And well, really the next like 50 plus years, but for you guys, 4 years. Next, we have to actually research the problem. So a lot of times we forget this one, but this is like 70%, 80, 90% of engineering is just researching and figuring out what the actual problem is. This one's super key and important. You're going to spend a lot of time on that one. So when we were designing our science building, the first part of researching the problem was figuring out, okay, for the users, which is students and teachers, what needs do we have? How do we teach science at San Marin? It's not the exact same as how they teach science at some other schools. So they wanted to know, what programs do you have? How do you teach? What methodologies do you use? What kind of tools and equipment would be necessary within the building so that we can try to put it all together for you? You know, are you going to use inside space, outside space, collaborative space? How do we set this up? And then we also did some research on like best practices, like what do other schools look like? What are some colleges? How do they set up their buildings? How does it impact the way that students feel and the way students learn? So there's a lot of research that kind of goes into before you even start to sketch things out. Let's look at what's out there. Let's see, oh, this is really cool. I didn't think about having that wall like that, but we could do it that way. Okay, then you develop some possible solutions. So the architects and engineers came back and they said, here are some ideas we have. We could do this thing on the concrete outside. We could do this kind of thing. We could do this or this. And they had a whole bunch of ideas of brainstorms of things that possibly could be part of our building. We could go 2-story. We could go 1-story. We could have the labs like this. We could have the labs combined with the classrooms. Then we selected the most promising solution. So based on our site, based on our needs, we went with a 10-classroom, single-story building that has kind of an L shape that pushes everybody back into the middle of campus. Kind of works perfectly for us. That was our best idea. Then they constructed a prototype. So a prototype is like a model. It's a way of showing your ideas, a first draft of the thing, usually on a smaller scale. So in our case, the prototype was drawings, sketches, blueprints, designs of the building, right? They didn't build the whole building and then be like, what do you think? And we were like, no, I don't like that wall, tear that out. You start with like the little model, and then you can say, okay, that doesn't make perfect sense to me. And then you modify it before you do the big one. Number 6, testing and evaluating the prototype. So we went through and said, okay, this part really works. This part doesn't work so much. And they evaluated it. If you put it on a shake table, will it hold up? Is it earthquake safe? What if we did beams this way? What if we had this coming in this way? Will it work? And does it meet the needs? Then they communicated the design out. So here's what we've got. And we said, yep, that looks just about right. And some parts didn't look right. There were some parts where we were like, oh, we initially had a wall there, but I actually don't think that we want a wall there. Can we make that a removable wall? Is it possible to have it open sometimes and close sometimes? And they said, yeah, we can do that. And so they went back and redesigned some parts. So step 8 is redesign. And then we just kept going through this process over and over and over. There were some parts where once we'd done some research, once we'd gotten to testing and evaluating, once they'd communicated the design, I was like, wait a second, we missed something. I need to go back to research. And I looked up, hey, how do I team teach? How can I get 60 kids in a room instead of just 30 if I want 2 teachers and 60 kids? Oh, we could do these removable wall things. Sweet. So we went back, researched, and then worked through it again. So this whole thing is really iterative, where you're going back around, back around, back around over and over again. So step 9 is repeat, right? This is happening over and over and over again until you finally get to a final product. All right. Or, you keep repeating even after you get a final product. You guys probably have a phone in your pocket. They made a first cell phone 25, 30, 40, I don't know, years ago. It sucked. I mean, it was awesome at the time, but it doesn't do any of the things that your phones can do now. So that kind of repeating process kept making things better and better and better and better. All right. So that is our introduction to physics and engineering notes. That should be page 1 of your new science notebook. And I will be back with another video very shortly.